This lesson is about how to calculate the volume of a prism. Now, a prism is defined as any polyhedron with two congruent parallel faces that we call bases. In other words, this here is a prism because this face or side and this face are parallel to each other and also congruent sizes. They're equal rectangles and they're parallel. Because it has two congruent parallel bases, this shape is a prism. This particular type of prism is called a rectangular prism. Not all prisms have rectangular bases. You name the prism after what shape the bases have. So while lots of prisms you'll see today are rectangular prisms where the bases that are parallel and equal are rectangles, some will have triangle parallel bases instead. Some will have regular polygon bases instead. For any type of prism, you actually follow the same process for calculating volume, which is really pretty cool. Now, there's two main categories that prisms fall into besides what type of shape their bases have. There's right prisms and there's oblique prisms. Right prisms are the ones you'll see more of at first right now in this lesson. Those are the ones where the lateral edges, in other words, the edges that are on the sides here and here, are altitudes. They're at right angles to the base and they're telling you how tall the shape is. It's called a right prism because these edges along the sides all make right angles with the base. Oblique prisms you could think of as leaning prisms. The edges here are not making right angles with the base. Because of that, instead of having rectangular sides around the lateral edges, you have parallelograms instead. Now, no matter what type of prism you have, you use the same formula for calculating volume. Your formula for volume of a prism is V equals capital B times H. Make sure you use a capital B here because when it's capital, it's not just talking about the length of a side, it's talking about the whole area of the base shape. And then H is the height of the prism. A quick note about volume, because it's been a while since you've had to calculate this. Volume is always going to be measured in cubic units, like meters cubed or inches cubed or feet cubed. The logic of it is this. If you're talking about distance and normal length, that's one-dimensional, so your units are to the invisible power of 1. When you're talking about area is a two-dimensional shape, so your units are to the power of 2. But when you're talking about volume, you're talking about how much space is inside of a shape. That's three-dimensional, so your units are to a power of 3. So we're going to use that formula to calculate the volume of this prism here. First off, I would take a highlighter, and I always like to highlight my bases, the two sides that are parallel and equal. And then I'll draw the base shape separately and label the sides. Once you have your drawing of the base rectangle, then calculate its area. That's telling you what the capital B is. Capital B is the area of the base. So because the base shape is a rectangle, your formula for the area is base times height. So you plug in the base of 12 and the height of 5 for that rectangle, and you get that the base area is 60. Now you have that ingredient, you could plug it into your formula for volume, capital B times H. So that would be 60 times the height of the prism, 6. Don't forget your units will be cubed. A quick note, there's something special about rectangular base prisms that won't work for other types of prisms, but with rectangular base prisms, you actually don't necessarily need to always choose these two sides, the top and bottom, as your bases, because if you look at the picture closely, we could have chosen, say, the left or right sides as our bases because they're also parallel and congruent to each other. Or we could have chosen the front and back sides because those are also parallel and congruent to each other. So let's say you had instead chosen to highlight as a basis the left and right sides. You'd actually get the same final answer in the end. That trick of using any two pair of opposite sides really only works with rectangular prisms. It won't work with the other types like triangular base prisms. Pause the video here and try question 2 on your own. Go ahead and check your answer on question 2. You highlight your bases. I usually choose the top and bottom sides for rectangular prisms, even though it's not necessarily the only way to solve. Once you find the area of the base you chose, then you plug it in to area of base times height of the prism. The height of the prism is always going to be the one number you haven't really used yet. Now, sometimes your prisms are not rectangular prisms. Sometimes when you look at your prism, the parallel and opposite sides that are equal are a different shape, like a triangle. Notice how here that the base sides are actually these two sides, not the top and bottom of the shape, because there is no top to the shape. There is no parallel equal rectangle to match that rectangle at the base. So you could think of this prism as being on its side. The only two sides that would work as bases are these two, because they're the only two that match each other perfectly. So you zoom in on the base picture. I like to draw it separately. Because it's a triangle, to find its area, you're using the formula area equals 1/2 base times height. So you plug that in, 1/2 times base of 8 times height of 15, and you get the area is 60. Plug that into your volume equation, area of base times height, 60 times 22, and you get your final answer. A quick note, because this prism is on its side, the 22 is the height. If you picked it up and set it upright, that would be how tall it is. Keep in mind that the height is really just the distance between the two bases. Pause the video here and try question 4 on your own. So first you highlighted your bases and zoomed in on the triangle shape of the base. Plug that all in and you should have gotten 540 cubic centimeters. So you've practiced solving volume for rectangular prisms, triangular prisms. Let's do one really fun one, a hexagonal prism. This one, when you look at it, the two bases that are parallel and equal are these two hexagons. To find the area of a regular polygon like a hexagon, you use 1/2 AP. You already have your apothem, it's 5.2. You need to calculate the perimeter. All the sides are 6 units long and there's 6 sides, so 6 times 6. You plug that into 1/2 AP and you get that the base area is 93.6. Now that you have the base area, you could plug that into volume equals area of base times height. Remember, the height here is really just the distance between the two bases, how tall the prism would be if you picked it up and set it upright. Sometimes you have what they call a composite space figure to calculate the volume of. That really just means it's a three-dimensional shape that is a combination of two or more simpler figures. This composite space figure is a combination of a triangular prism and a rectangular prism. For the triangular prism, you know that the base of the triangle is 5 because if this edge of the rectangular prism is 5, then so is the one above it, which works as the base of the triangle as well. So you plug that into 1/2 base times height. You get that the area of the triangle is 5, and you plug that into your volume formula. Area of the base times height, which is really just the distance between the triangle bases, would be 6. So 5 times 6 would be 30. So 30 cubic meters for the volume of the triangular prism. Then you calculate the volume of the rectangular prism. The area of that base would be base times height, 5 times 6, 30. Plug that into your volume formula, area of base times height of 3. You get 90 cubic meters. So for your final answer for the volume or the amount of space in the entire shape, you just add those two prisms up. So your complete volume for the composite figure is 30 plus 90, or 120 cubic meters. Great job today, everybody. Don't forget to turn in a picture of your notes on Schoology.